This is a very frequently asked question, finding when log x equals a is a constant, x to the n has only one real solution, or a variant, and it's very badly answered. And just to give you a little bit of a preview of where we're going, we are going to, in about 3 minutes' time, be answering these two questions here, which are similar and based on the same idea, by inspection, which solves an awful lot of time. But first of all, let's go and answer the question at hand. Okay, so question 1. For what positive a does log x equal ax to the n, where n is in the positive integers, have exactly one real solution for x? Okay, and we're given 4 answers here. So let's just have a look basically at what the graphs look like. So basically log x is like this. There's log x, and here's the pointer 1, 0. That is log x, and let's just get here. So ax to the n, if n is even, oops, well, that should be on the origin. That is ax to the n for n even, and then if n is odd, then ax to the n looks something along the lines of that. But either way, because log x is not defined for negative x, we can ignore the negative x here, and basically ax to the n, whether it's even or odd, looks exactly the same, pretty much. So it will be something along the lines of that. And basically what we can note is that log x starts with a gradient of sort of positive infinity, basically, and the gradient gradually reduces until it goes to about 0, but it always stays positive and it always reduces, whereas x to the n, whether it's even or odd, the gradient at x equals 0 starts at 0 and the gradient keeps going up. So therefore, by definition, there is bound to be one point where the gradient is the same. So the first thing we're going to do is we are going to find out what the point where the gradient is the same is, and then the question becomes, at the point where the gradient is the same, is the y value also the same? So basically if we have log x here, and we have, and let's see if I can actually draw this right there, that's ax to the n. Here we have not only at this point x is the gradient of log x the same as the gradient of ax to the n, but also the y value is the same, and so therefore we have, therefore we have only one real solution, and we need to find out what value of a causes that one real solution, because we will find for other values of a, again if we stick log x in here, for other values of a, if a is high it will go like that and there'll be no real solutions, and if a is low it will go like this and there will be two real solutions. Okay, so let's get on with the question in hand. Basically what we need to do first, we need to differentiate. So let's have a look. We've got log x equals ax to the n. So first of all, let's differentiate. So we have the differential with respect to x of log x, well, that equals 1 over x, and the differential with respect to x of ax to the n is na x to the n minus 1, and we need to find when those two gradients are the same, i.e. when 1 over x equals an to the x minus 1, i.e. when x to the n equals 1 over an, or the x equals the nth root of 1 over an. So that is the point at which the gradients are the same. And now what we need to do is we need to plug that point into log x and ax to the n and find out when the y values are also the same. Okay, so let's do that. So log of the nth root of 1 over a to the n equals a times by the nth root of 1 over a to the n, an to the power of n. Now this bit's simple, nth root of something to the power of n, that basically just equals a over an, which equals 1 over n, and here if we take this nth will be to the power of 1 over n, which we can take out here, so that will be 1 over n log of 1 over an equals 1 over n from down here, and the 1 over n cancels, so we get that log of 1 over an equals 1. Well, log to the power of e of anything equals 1, then this must equal e, so 1 over an equals e, i.e. a equals 1 over ne, which is our answer. The value of a for which there is one solution, i.e. both the gradient and the y value are the same, is 1 over ne, which is answer B, which I find Very pleasing indeed. Okay, so now as promised, using that we can have a look at some other questions and solve them by inspection, which is a great timetable in multiple choice exams. So question 2, for what positive values of a does log x equals ax to the 4? Well, here we've just got n equal 4, have 2 real solutions. Okay, well if we just, hang on a sec, let's just draw a little graph here. So here's log x again here. If we have a high value of a, well obviously then x to the n is going to be equal to that, and if we have a low value of a, then x to the n is going to be equal to that, and there's only one value of a where x to the n, and let's see if I can draw this right, where x to the n, that's for an where x to the n and log x have only one real value, and of course it doesn't matter whether it's even or if it's odd, it's exactly the same thing. So for high a, and here for low a, so basically all we need to say here, okay, well we know there's going to be one real solution. We've already worked that out and answered the other question. There will be one real solution if a equals 1 over 4e, because the answer was a equals 1 over ne, and here n equals 4. So therefore there's 2 solutions when a is less than that, i.e. when a is between 0 and 1 over 4e. That is the answer to this question here by inspection, saves a lot of time. And question 3, for what positive a does log x equal ax to the 15? Well, here we're having n equals 15, have no real solutions. Okay, well that's just discussed. For a high a, there'll be no real solutions. So basically when a is greater than 1 over 15e, there will be no real solutions to this equation here. It's very, very useful indeed. And certainly if you do get these on multiple choice questions, it saves a hell of a lot of time, because you know, sometimes these are quite difficult to think of, and if you just remember this formula that a equals 1 over ne is when log x equals ax to the n has only one real solution, you can answer these very quickly. Okay, well I hope you found this useful. If you have, please like this video and subscribe to the Gresty Academy YouTube channel. Thank you.